Hello and welcome to this session, the first in two, specifically looking at strategies for creating terrain in SketchUp. I apologize, I've just noticed that the big image I've put on my screen has got the wrong date. That's tomorrow. So there is a second session tomorrow, which if you haven't signed up for, then you'll find it at the Elmtec events webpage. Firstly, I'd like to thank Elmtec, who are the UK distributors of SketchUp, for hosting this and the next three events. So there are one tomorrow and there's two, one on Monday and one on Tuesday, where I'll be doing a short 1 hour session on plants. So it's over 2 days, and I'll be looking at using Warehouse 3D, 2D, creating plant plans, and then managing the use of plants and when it's appropriate and not appropriate. This session is going to be focused on the creation of terrain. And by that, I mean terrain which you have data available for, whether that's a contour or a set of spot heights, or no information whatsoever, and we'll talk about that in a second. And tomorrow there will be more focus on manipulating that terrain and changing it and getting it to reflect some of the things that you would like to do with it, or an alteration of the design. And also patching up terrain if there's a problem or you need to take a section out and put a new section in. Now, your terrain model is, you have to ask yourself at the beginning of a project, why do you need to create a terrain model? And the first reason might be that you need a record of what is already there. And you may enhance that understanding by commissioning a survey, and you get a set of data back, which will then maybe give you things like contours and data sets with spot heights. Or you may undertake the survey yourself. However, it's always worth considering that if your perceived design changes are going to completely alter the landscape, then is it worth going to the trouble of creating a terrain when that terrain will actually no longer exist? And that may be quite particular to smaller gardens where you're going to terrace, you're going to dig out certain sections. And you still may want to make a comparison between the before and after, or do an analysis that helps with some cut and fill or understanding the volume. But it's not always necessary to create terrain models. I won't make any bones about it. Terrain modeling can be very tricky, and you need to have patience and understanding of some of the techniques and practice. You rarely can make a terrain model simply with native SketchUp tools. There are some tools and we will look at those, but to create better terrains or terrains that represent a smoother landscape, then we have to employ plugins and extensions. And I will be highlighting those, and I will make a list of them. And when these are posted to YouTube, there will be a list of all of the plugins and extensions that I highlight. So I'm going to get started. Now, you don't always have data available, or it could be at the beginning of a project when you need to just do an analysis that isn't necessarily particularly scientific, it's not necessary to be accurate, but you'd like to understand what the general terrain characteristics of the site that you're looking at or considering taking on board. And there's a neat little function in SketchUp which allows you to use existing terrain data for a site. And I'm going to create from scratch. So I'm going to use a plot not far from where I'm located. And I'm going to import the terrain, and then I'm going to create some contours. And so that will form the basis of at least appreciating a piece of land, maybe before I begin the project, or even before I even commission a full survey. I'm using SketchUp Pro 2020. I've not got any particular setup. I've got no enhanced graphic card. I'm just using 32 gigabytes of RAM. When you're using or creating terrain, it can create a lot of polygons, especially with larger areas of landscape. And that gets even more onerous when you're starting to use plants. So if you're working on something with maybe only 8 gigabytes of RAM, then if you're starting to consider terrain and plant modeling, then you firstly have to be very aware of how to manage those models through the use of scenes and tags and layers. But you may really want to consider upgrading your RAM. Now, I'm going to geolocate my empty session of SketchUp. So I'm right at the beginning of a project, and I want to understand the terrain of the site that I'm going to work on. And if I go to File and Geo Location, there's an option to say Add Location. And a window appears, and you get to type in a postcode. So as it happens, it's already set to my general location. So I'm just going to select a region. And I'm then going to use the little white pins, and I'm just going to hone in on a little area. I can move the image around. I know this part of the street about half a mile away, and it's quite steep, so it makes an interesting model. And then I'm just going to say import. So there are very few options, nothing to go wrong. It takes a few seconds. And there it is. What's come in is a very large green rectangle. If you look at your tag structure, it is automatically added 2 tags. And those are location snapshot, which is visible, and location terrain. Now, I've got by default, I've got my textures switched off. So I only see the plain block colors. But if I switch my textures on, you can see it's peeled off that part of the aerial photograph and brought it in. And it automatically aligns itself to north. And the north in the default north in SketchUp is along the green axis. In a previous session, I've talked about changing that default using the Solar North plugin. This has by default reprogrammed SketchUp. So the geolocation function takes the default position of the axes, which is probably in the car park outside SketchUp HQ in Boulder, Colorado, and repositions it to the center point of your postcode. So now we're looking at, we can do correct shadows and all of those sorts of things for Sussex rather than Colorado. This image is pretty poor quality. I don't think I ever use these aerial images. The purpose of bringing it in, one is to reprogram the location, but really I'm interested in the second of these tags. And if I switch off location snapshot and switch on location terrain, you can see that what has happened is it's brought in the terrain model of that piece of land. Now, this is free data. It's not the greatest piece of terrain modeling in that its accuracy is dependent on where you live to some extent. Places like large cities will have geolocation LiDAR data being fed back into these aerial systems on a frequent basis. If you live further out in the country, you may be lucky that things like Google Earth don't update from one year to the next. If I switch off my picture, you can see some of the characteristics. You have to remember how these data sets are recorded, and it's usually, it used to be aircraft, it's probably drones now, and they fly over and they put a laser pulse down, and where that laser pulse hits the ground, it takes a reading, and it depends on the resolution. So if that laser pulse is only recording every 10 meters, then the bits in between are really guesswork. They're getting better. If I go to View Hidden Geometry, I can see the underlying grid for this terrain, and it's even distribution. So it's a nice model, although the accuracy is somewhat debatable. But it gives you that opportunity to maybe, and if I go back to the site image, you'll notice that the road is lying in the correct location on the terrain, which is nice to see. There's no misalignment. Use this, or you might want to do something to it. And probably the best way to do that is to use contours. And we didn't get contours. This was created from spot heights, and it might help. It helps me when I'm creating or understanding or trying to visualize the landscape if I've got the contours. So what we need to do is create the contours on this piece of land. If I click on the terrain, it does something that you might not have seen before, which is instead of going blue, it goes red. And that indicates that the layer, or the geometry rather, is locked. You can't change it, you can't move it. And that's simply a case of right-hand clicking and saying unlock, and we get the familiar blue box, which means it's grouped. And if I look over to my entity info, it tells me this is a group. What I need to do is create some contours. And the easiest way to do that is to make a very large rectangle. And I'm going to position that rectangle. I'm going to drag it down so that it's just below the level of the lowest point of my terrain. It doesn't matter if I miss it, so I know that it sits below. And then I'm going to take this rectangle, double click it to make sure I select everything, and then I'm going to drag up a copy in the blue direction, and then I have to decide how frequently do I want these contours. So if I go all the way to the top, I can see that there's approximately a 10-meter height difference. So I'm going to offset my copy by 1 meter. So simply type 1 and enter. And then if I hit times 10, maybe times 12, it then makes, it repeats that process. So I get a whole stack of pages, really, like pieces of paper. If I open up or look down the gap to pick my terrain, if I maybe explode it so it's no longer grouped, and I'm just going to make sure that I delete the little figure Laura because I don't want her to get sliced. If I then pick all of the geometry, right hand click and say intersect, hopefully it will go away and it will intersect my sheet geometry with my terrain modeling. And where it creates the intersection, it will create a line. And it's still going, and there we go. Now, what I have to do is now unpeel my model. So I'm going to go to my erase command, and I'm just going to go down the side and delete the corners, and then I can delete the corners on the other side. And what I'm left with is bare contours. Got some strange little bumps happening over here, and I could use those. It helps me visualize, certainly. You know, some of these undulations are quite subtle. I've got a much better appreciation of where the road lies, and I can go back and still see the image that I brought in. So that's an easy way of creating an approximation of the terrain. It's not as accurate as a survey, but it's better than nothing. So we're now going to go and look at taking that idea of using contours one stage further. So let me just close this one down, and I'm just going to bring over this model, which I'm hoping you can see. Right, contours. You usually get contours from a professional survey, and you have to make sure that you ask for them. Not all surveyors will give you contours, and it can be quite difficult to have them applied retrospectively to a file. So if you're commissioning a survey, make sure that you ask for contours. And specifically, just to make your life a little bit easier, make sure that you ask for contours that are set on their own layer and are set in 3D. It doesn't take much on the behalf of the surveyor, but it saves you, the stage that we may have to go through in a minute. So this is an example of a contour that's come in directly from the surveyor's drawing. I've just stripped out everything else, and I've then taken those 3D contours and brought them into this session of SketchUp. I am going to deal with importing DWG files into SketchUp for the purposes of extracting things like contours and building information. But that's going to be a separate session. And if you go to my Eventbrite page, you'll get a link to that, and that will also be free. But you can see here we've got gaps, little tiny gaps in our contours. We've got big open spaces where either there's so much vegetation or there's probably a building pad which might be subject to a separate set of lines. But here we simply got the contours. The first thing that I would always do is click on a contour. And it depends on how the lines were created in the original package. And this it's not bad, but it's not great because we've got a fragmented line. We don't have a polyline. We've got a line, or each of these contour lines is made up of these fractious little pieces. And what that means is if we ran a contour skinning tool in SketchUp, it would go to the end point of every single line and make a triangle with the nearest line above and the nearest line below. So we end up with a lot of triangles. So it's helpful to try and reduce the poly counts. And a technique for doing that is to simplify or weld these lines together. And there's a couple of ways of doing that. If I select this geometry, I can run one of several little applications, and I'm sure there are more, but in my workflow, I know of two. So if I go to my extensions list, I've got, whoops, here we go, tools, here we go, Edge Tools. Edge Tools is by TomTom, I think. It's a plugin available from the SketchUp warehouse. And in it, we've got something called Simplify Curves. And if I click, it's really saying what's the maximum deviation. I pretty much go with the default. So I'm not that worried about explaining how all of these work, but you can alter the deviation between lines. If I say OK, it's reduced the number of curves by 3,189, which is a significant reduction. And it didn't really change much. You know, you might have sort of seen a slight jump. If I reselect that geometry and go to Tools, the other thing I can do in Edge Tools is close, where we go, close all gaps or find edge gaps. So I'm going to close all edge gaps, and it's going to give me a default. So I'm going to say, you know, it's picked whatever number I had last time. So it was 0.6 meters because this is quite a large landscape. If I say OK, you'll notice that things like this little line here get closed. So that saves me hunting down any of these stray edges. I also noticed that it's closed up some of these where they should have remained open. Oops. So these lines here, and we've got another one here. So it's not simply a case of just running some of these programs. You do have to be aware of the effect that having contours pinched together can have. Another plugin, and I've just noticed that I can't quite see it. Oh, here we go. Simplify contours. So that's a plugin that is written by the SketchUp team, and it does virtually the same thing, except it only does the simplification. It reduces the number of curves in a line. It doesn't have any of the other options. If I click this curve, you'll see that instead of picking a single line, it sort of welded them all together. And the Simplify Contours does something very similar. So, next stage. In SketchUp, there is a set of tools called the Sandbox. And if you can't see them, they'll be under your View, Tool Palettes, and on a Mac, that will be on the list. And on a PC, that will be in the pull-down list where you tick the box for Sandbox. And I should have them active on my screen somewhere. There they are. I'll just bring them in. There they go. And there are 7 icons, and we'll cover 1 or 2 today, and we'll look at the rest to some extent tomorrow. I simply pick my curves and select the first icon, and that's from contours. And what happens is SketchUp looks at a line, sees where the break is, and then draws triangles up to the nearest break line above and the nearest break line below. And you end up with triangles. And where you've got even distribution of contours, you frequently get even distribution of triangles. But as you'll see here, we had a large empty space. And so what the software has done is bridge the gap, and it creates larger triangles. So it's not an even mesh as we saw when we looked at the imported aerial photograph terrain. What's also important to appreciate with this technique is my terrain wasn't this shape before I put this surface over it. It had these concave sections. And just to look back at the original version, we've got these areas. So it's almost like stretching a balloon over a wireframe. SketchUp will create these taut surfaces where actually there shouldn't be surfaces. It creates the terrain as a new group. So I can take that off. So that's my actual terrain model without the contours, and it's already been made into a group. If I go into the group, and I'm now in View Hidden Geometry, so that's it without the hidden geometry. So if I go into View Hidden Geometry, I need to delete out some of these lines, and if I just delete them, it then starts to take them back to the original lines. And in this case, that's not too difficult because my facets are quite large, and I can delete all of these. But in some instances, and here's one, some of these little facets can be tiny. And I think I saw some at the, we've got some here, because it creates really sharp, tight triangles. And it just takes some familiarity to see them. You get a sort of gray ghosting effect. And I can't quite remember what the terrain was doing. Yeah, it's something like that. So I don't want to delete too many. If you delete too many, you start to remove the triangles. If I deleted this one by accident, you can see that it takes away that whole facet. So I just need to put that back. But that's not a bad representation of the site. if that's all you need. This kind of terrain is quite difficult to manipulate because when you pull on the triangles, you get an uneven effect depending on where the positions of the adjoining points are. But if you only want a record, then it's a quick, easy method to use. We're going to do it differently. Excuse me. So here is a replica of that data set without any editing. So on this one, I'm going to use make sure I don't select the surrounding one. I'm going to use the simplify contour version. There it is. Ask me for the angle of deviation. So I'm just going to go with the default. I'm not going to patch up anything. So I'm going to leave all the gaps, but this time I'm going to use a separate extension. So I'm going to select the geometry and I'm going to go to my this extension, and not all extensions put themselves where you think they should go. So when you download your first extension, this little extension label appears at your top menu bar. Not all extensions will put themselves in this list. So if I go to my tools, I've got a few options here that you might not have. And one of them is there's a very prolific programmer, and his on-screen name is Fredo6, and he writes a whole load of stuff that is, I think everything is free. I'm not sure there's anything of his that you have to pay for, and they're all essential. But one of the great ones, especially for this kind of work, is Toposhaper. And this comes from not the SketchUp extension warehouse, but these come from the SketchUcation download, plugin downloads. So you'd have to go over and join the SketchUcation. It's all free, but you just need to make sure you sign up. But here we have, having selected the curves, the contours, pick Toposhaper, and we've got a couple of options. So I'm going to pick terrain from ISO contours. And off it goes. It starts to do things. And I wouldn't worry too much about it. It's doing a cleansing. I'm just going to see if I can see all of my options. I almost invariably just go with calculate terrain. It gives you lots of options to fix some lines. So you see that these little red lines, it's found that there are gaps, and it's asking if I mind it, or am I happy with the fix that it's offering. So I'm just going to say calculate terrain. And there we go. That's generated the mesh. So I'm just going to say, yeah, we'll go with that. And there is my which is different to the one that's generated by Sandbox. The first thing that is noticeable is you end up with an even mesh. So it simplifies, and it probably has a much lower polygon count. So it's a very nice which is it takes the terrain and then extends it down onto the ground. There are loads of options when you're using this. If you haven't got contours, it will generate them for you, which we will look at when we use a different side of the software shortly. And again, it makes it into a group. So Toposhaper probably, it also doesn't cause these stretched surfaces so that you don't have to worry about deleting them out. So Toposhaper makes a very nice terrain model. Now, you only get 3D contours if you ask for them, or you've got a surveyor who appreciates where his drawings might end up. So frequently you'll get contours that lie flat. So here's a good example. Same contours, but lying on the ground. You can take the contour line, weld it together, or you can simplify all of these contours and then lift them up one at a time. So if I did a quick extension, simplify contours, go with the default, pick the line, and then I can move it up into 3D space, making sure that I stick to the blue axes, and I might move it up 1 meter. And then I might move the second one up 2 meters, etc. So obviously that would take a while. There is a plugin that can help. So I just need to open it up, and wherever it's called Elevate, and I used it last night. Oh, there we go, right at the bottom, Elevate Contours. Now, Elevate Contours is an old plugin. I think it claims in the 3D extension warehouse that it's only compatible up to 2017. I downloaded it just to try, and it still works. Well, it did work last night, so we'll try it again. So Elevate Contours, and I've made the first mistake. You have to learn how to use these plugins, and with this one, you click from the origin and you draw a line across your contours. And at the end of the line, it obviously your construction line, it creates a point. So if I now select that point and then run the extension, try again, extension, Elevate Contours, extension, Elevate Contours. It's asking me what the increments of my contours are going to be. So I'm going to say, I don't know, 0.5. Oh, well, let's go with this, I think, go with 0.5 meters and say OK. And there we go. There we've immediately got all of our lines have been elevated, except some of them haven't. And this is one of the compromises. When I drew my line across the geometry, if a contour line crossed the construction line, then it was picked by the process. If the line didn't cross, then it gets left behind. And these lines didn't cross. So what I could have, if I undo that, is you can see here I just missed them. It might have been appropriate to draw in some fake contours that just gave an indication of what is happening in this space, and then the whole thing would have been lifted up into space. But once it's up into space, then you can then use the Topo Shaper or the Sandbox tools. Right. There are other ways of using data. So let me just bring in the next element. Let me go to see my tags panel. Okay. Now, one thing that can be really useful is to take this technique of using contours, but apply it not to a much larger landscape, but to apply it to a very small landscape. And so, you know, a small garden, backyard, because you don't always get full surveys for projects. Sometimes you have to do the surveys yourself. And when you do the surveys yourself, you're going to get a range of different sorts of data. And mostly you're probably going to measure things like spot heights. You're not going to be able to generate your own contours. But depending on the nature of the project, you can still use the contour tool. And a good example of that is this little sequence that I will show you now. And I'm just going to zoom out because this is a technique that I use for pretty much all complex geometry, irrespective of whether it's terrain or not. And it's not that I put this together to give you an idea of the sequence of completion. It's that when you're doing something quite complex, sometimes you don't necessarily appreciate what is about to happen. So it helps that if you complete one piece of work and then make a copy and then start the sequence, the next stage of the sequence on that copy, so that you end up with a stage-by-stage process. And that if anything goes wrong or you don't quite get the result, then you can quickly visually pick up where you think it went wrong and rework the geometry or make a copy of it and try a different method. And in particular, terrain doesn't always give you the result that you want. And if you scroll back, then you can see where the mistake was. But you can also copy and paste the geometry, so you don't end up with these long processes of recreating whole surfaces or resetting your contours. And I put all of those sorts of things on their own tag, and I might call it terrain construction. And then when I'm done and I've got the result I want, I can pick all of that geometry and put it onto the tag that says terrain construction. I can switch it off and it's there if I ever need to go back to it. But in this case, I'll very quickly talk you through this process. And I call it the Shoebox method. And it applies to garden or landscape spaces where there is a change of level, but the change of level is in one plane only. It's not up and down in lots of different directions. So if this is a garden and the house is at the bottom and we've got some fences or walls around it, it changes level from the house all the way to the back, but it doesn't really change much side to side. And that means that we're really creating a complex plane from side to side without really worrying about any dips and peaks in the middle. So how does that work? Well, I think it changes the way you do a survey. And the first thing to do is you pull up the geometry into a box. So you draw a plan of the garden and then extend it. And I call this method the Shoebox method because essentially I'm creating a shoebox and then drawing on the side of it. The second stage is to then mark out the position of, in this case, fence panels. So I've been to a garden and I've noticed that it's got a whole load of fence panels around it. So measure the distance between fence panels, and it can be 2 meters, it can be 2.1 meters, and just make sure that they're the same fence panels on all sides. And all you're going to do is go around and draw in every 2 meters and create a vertical grid. So you're drawing on the side of the box and putting in all of the fence panels. And that is going to form your grid. We're not worried about what happens in the middle. And then all I need to do is draw in the fence panels. So start at any point. It doesn't, the height of these walls on the shoebox is completely immaterial. You'll edit them down later. So start drawing anywhere, just start, and then draw what you have seen in your survey. And the survey is you doing a sequence of drawings, looking as if you're looking at each of these fence panels and you've got dimensions. And to give you an example, your drawing might look something like this, that you've drawn in every 2 meters on your little survey drawing, and you've then said, right, the first fence panel is 1.92 meters from the top of the panel to the ground. And then you might do it every single panel, or you might then take one wherever there's a change of level, because you need to check that the fence panels are level. So maybe having a spirit level helps. But it's a quick and easy way of taking a survey on a site using the existing site as a reference. So in this case, I've just taken dimensions down from each of the fence panels. So just to go back to the model, draw in those lines and the height difference between one set of fence panels and the next. And then you're going to measure down and record the position of the ground. And I use a little symbol like this, and I simply create this or have it in a library, and I bring it in to position. So it's at the top of the fence panel, and then I know what my offset to the ground is. So let's say it's 2.1 meters. And then I take a copy of this, put it in position at the next one, and drag the next one down. And I go around and look at my little survey drawing and reference each of the positions that I've marked and put one of these circles in place. And what you end up with is something like this. So I've put all of the points in place and then I've dragged them down into position. So this is the actual ground. So the size of the shoebox doesn't matter because this base level was simply to help us create the geometry. The next stage is I'm going to join up all of these lines. Usually helps if you group the underlying geometry, and then you're going to pick up the center point and snap, and just snap, and you're going to go round the entire garden, and it probably takes about 30 seconds as you go round, and you end up with this, a simple perimeter geometry. And now I can create my terrain because this is a closed loop. So I can triple click on the line. Because the underlying geometry is already grouped, it won't select it. So it only picks this line. And then I can run the from contours. And instead of going up and down between contours, it simply goes side to side. It takes the shortest route to the next point. And you can see that it's planar as it goes across the garden. It can slope side to side, but it's not picking up any details, which is why it's good for smaller spaces or where the space is relatively planar in one direction. Doesn't matter if it slopes left to right or right to left or back to front or front to back, but it works best on planar gardens. And so if I switch off my hidden geometry, view hidden geometry, and then I can give it a nice color just so that I can pick, there we go, and so it looks a little bit more of a garden space. And then simply pick these geometry lines and erase them. So whoops, go into the group, and then I can edit out all of this geometry back down to the actual fence panel height. And that would give me a image something like this. So there's my garden space, and it may be useful for working out cut and fill or volume, or I can understand if I'm going to make a terrace in the center. If I take a horizontal line and place it on the surface, I can then work out what the fall is across that point. From that point down, so I can start to understand that that's just over a meter. So if I'm going to start building steps or retaining walls or sleeper walls, then I've got an appreciation of what kind of structure, what kind of foundations, what kind of material I'm retaining. So I use that one quite a lot. Now, the other method of creating terrain is where you've got points. So I'm just going to close this down. I'm going to open up another model. So just bear with me. And here we go. So this is a set of data points. These have come in from, these are literally cut and paste from a survey. If you ask for data points, they are almost always in 3D. And most surveyors will put the data points, spot heights, spot levels, they're called several different things, onto their own layer. So they usually, you can switch everything else and get straight to the terrain. A difference between contours and spot heights, it's useful to understand. A surveyor will mark points on the ground with a staff, and those points will be accurately recorded in terms of heights relative to the datum that they've set. So they're absolute. They are a record of that level at that point. When you generate contours, it takes that same data set and then it works out the approximate link to all of the same points that are at the same level. And where 2 points aren't at the same level, it will then interpolate between them and create a contour. So contours are approximations between data points, and data points are absolute. So you'll get a very accurate terrain model from a data point. You tend to get a smoother model from a contour. So how do we turn this into a terrain? Before Toposhaper, it would have been tedious. It would have probably taken 2 or 3 hours to do so. But Toposhaper came along and it's very simple. Simply select your points and make them into a group. So I'm going to say make group. And then I'm going to go to Tools, Fredo, Toposhaper, and the second option is create a tri-mesh terrain from cloud points. And so a set of points in space is also called a cloud. So if I pick that, it immediately kicks in. There's a whole load of options that I can play around with triangulation and smoothing. You get the option to add a skirt, and you get the option to add contours. So I'm going to pick contours, and I'm going to get the contours set at, this looks quite flat, so I'm going to get them set at 0.5 of a meter. I'm going to say OK, and then I'm going to ask it to auto calculate. It's obviously going away and doing it. The more points you have, the longer this can take. So I'm quite happy with that. So I'm going to say thank you very much. And there's my terrain, a different terrain than the one we used, but generated from spot heights, a sort of a plateau, and this is a riverbed, or the bank of a river. So it looks a lot more dramatic. You'll notice it's triangulated literally between 2 points. So the software has gone between 2 points. It's found the nearest 2 points and created a triangle. So we don't have that nice smooth terrain, but as a record, it's very accurate. So that can be a neat way of doing it. But you don't always get the ISO points. And again, this is what comes in from a surveyor. If you're creating your own survey and you can't or don't use the perimeter shoebox method, then you're likely to have gone around the garden and measured either using a zip line or, sorry, zip level, or a dumpy level or some other method of measuring down from a datum. So let me just open up that. So I'm going to show you how to create 3D spot heights and the terrain from your own level points. And it's a little, I was going to say tedious, but it's not, because when you're doing your own survey, you tend not to generate thousands of points, and you frequently don't even generate hundreds. So you may have, 10s, 20s, 30 points. So it doesn't usually take that long. But let's pretend that we've got a square rectangular garden, and you want to try and create your points in as grid-like a fashion as you can. One, because it helps set out the points when you're measuring up the garden. You just put a tape measure and you can go down every 2 meters, every 5 meters. But secondly, it also helps enormously when you're setting out those points in the computer. So sometimes you adapt the way you work on site because you know that it helps streamline the terrain making process. So if we've got the outer line of the garden is a simple rectangle, it could be any shape. And then here I've just put nominal grid lines. And then I pretended that we have just taken a spot height at each of those grid lines. And you can see here, this is just the start. All of these grid lines are flat and all of the points are in their start position. They're flat on the ground and they're ready to be lifted or elevated, depending on what your measurements are. Now, in reality, those points are not going to all be in a grid. You're going to end up with stray ones, or there's a rock, or you have to move something. So your points are going to be slightly higgledy-piggledy. Now, the technique here is very simple. Once you've done your basic arithmetic to work out the height elevation that goes up from your datum, or if you set your datum higher than your calculation down from the datum. But what you're essentially doing is picking these points and you're moving them up into 3D space by whatever. So if you're moving up 1.2. There's your 1.2 level. So you're lifting up every point by the amount that you have surveyed. To save time, I've already done one. So if I just go over here, and there we go. I've just elevated these points up in space. And if we look down in plan, not all of my points in this version are on the grid. So we've got some stray points that are sort of offset. So here we go. They're all where they should be. Now, following the way you ought to make, or I think you ought to make terrain, you should copy this stage and work on this version. So the other tip is I've done something, I've elevated all of these points into 3D space, and now I'm about to do something. Golden rule in computing is save before you do and save when you've done. I've just finished doing something and I'm about to start something else, so save. That way, if anything goes wrong, especially when you're using some plugins, and especially if you're using them on large data sets, they can just sit there and freeze, or the thing can crash. So you don't want to then have to go back and reset the positions of all of these points in space. So the next stage is very simple. We've done it before. Excuse me. You simply join up these points. Now I've joined up 4. So what you have to do is make triangles. So if I click here, it then fills in those triangles. And what you need to do is just fill in the triangles and make sure that you get the right points and go through. Whoops, there we go. A tip with doing this is make sure all your diagonals go in the same direction. Don't have this diagonal going left to right and this one coming from the top left down to the bottom right, because you will end up creating quite disjointed terrain. So it's very simple. What is really useful about this method is I'm just going to go down the center one here. So if I go from here to here, because I'm drawing on top of groups, I don't have to keep picking the line tool each time. And if I go down to the line at the bottom, you can see that it's automatically created a landscape section. So I've joined the top and then it's created the base. And if we take, I'm going to go to this one up here, just because all the points are in a line, but I can do the same here. Okay. You have to zoom in sometimes to make sure that you pick the right point. It's quite easy to miss. And then I'm going to join down, and then I'm going to go back across here, and oops, I'm going to do the same again. And then it's now created essentially a landscape section in the opposite direction. And so you simply build up your terrain using these offset points. Now, if I quickly do a little section here, so I'm going to go from that one to that one, oops, to that one, and go across. I'm just going to fill in this little block of points here. And again, oops, meant to draw that one in. So you get the idea. You start to create an exaggerated version of the little triangles that you saw on the larger meshes when we were using contours. But if I pick just those elements, if I right-hand click, then I can say smooth and soften edges. And what that does is it opens up a little window, and you've got a slider that you can play around with. and you've also got the coplanar edges as well. So it's a combination of moving the slider until some of these lines disappear. And what I'm looking for is all of them to go dotted. So be something like that. And then if I view hidden geometry, switch it off, what you end up with is a smoothed geometry. Sometimes this happens, which is all of my geometries going white or this gray color, and then frequently up pops one surface that's gone gray. And it doesn't just happen with terrain modeling, it happens with other forms of modeling as well. So I'm going to go view hidden geometry again, so I can see the dotted lines. All that's happened is the face has become reversed. It's, without going into it in too much detail, it really has no consequence at this stage. If I applied a nice terrain color to this, it applies the color in the same way, whether the face is reversed or not. It does affect sometimes when you're doing calculations or interrogating the model. So good practice would be simply to pick the surfaces that are not the color that you want and right-hand click and say reverse faces. And therefore they all start to face in the same direction. And I've just noticed that we're virtually at the hour. I pretty much got where I wanted to. I'm happy to stay here and answer some questions. But tomorrow, I'm going to cover ways of manipulating terrain. So once you've created a terrain, then creating terrain is actually the easiest part of it. Creating the data and creating the surface. There are techniques, and the main techniques are the ones I've shown you. Editing the terrain and starting to cut and patch and blend is trickier. And there's some nice tools that we can use to do that. And we'll talk about those tomorrow. Some of them are Sandbox tools, some of them are plugins that we bring in. And I'll try and go through more of the Sandbox tools as well. So if anybody's got any questions, I'll try and answer them.
Hi, Paul. It's Lauren from Elmtec. I think it might be easier if I read them out for you, if that's okay. So we've got one from Mary. Hi, Mary. She's asked, how do you find the little symbol that you've used to mark points?
How do I make the little symbols?
Yes.
The little symbols are, I use them a lot. I use them in drawings as data reference points. They're also quite striking so that you really don't forget that you've got a marker, and that's essentially what they are. And the way I make them is I go into my, I start with a circle, and when you draw circles, a little tip, don't just randomly drag a circle out into space. Drag a circle out and then make sure that the line that you're dragging out goes either red or green, which means that the facets, if you can see the facet on the circle, is pointed and set on a green or red axis. So I'm just going to draw a very big one. So now I've got my circle. If I go to my line tool, I can draw from the center point, and if I can't see the center point, just simply touching the outside of the circle activates the center point. Now, when I drag my mouse out, if I go along either the red or the green axes, my line will automatically align to a facet. It won't go at some strange position. So I'm going to go out just beyond the perimeter of the circle. Now, I could repeat that process for each of the lines, or if I select the line, it's been split because it crosses the circle. So I use the Shift key to get both parts. If I use the rotate tool, which is on my large tool set on the left, place the rotation point in the middle, and then, whoops, start that again. Draw across, pick my line, and then pick my rotation. I want to make a copy. So if I hit the modify key, which on a Mac is Alt as Command on a PC, and then when I drag, it drags a copy, and then I simply snap that at 90 degrees, and then I ask it to repeat it another 2 times, 3 times. And then when these lines cross the circle, they will have split the geometry. So I can simply paint 2 of them in black and 2 of them in white. And then I can pick everything, triple click will select all the geometry, and then I can make it into a group. And if I want it to be a bit smaller, I can hit the scale tool and just scale it down.
Perfect.
There's my code.
Thank you. I hope that answered your question, Mary. Quick question here from Joanna. Hi, Joanna. Where does Paul get his pencil set from, please?
Okay, if you use a Mac, then your color options, which are under Window and Paint Bucket, sorry, Paint Bucket tool. There we go, Paint Bucket tool. If you hit the Paint Bucket tool on a PC, you don't get a crayon set, I'm afraid. You get a slightly different interface. These are just the default colors. So on a PC, if you went to your texture palette, I don't think you've got the brick, you've just got a set of brown folders. And then the brown folders will have names underneath, and the names are the same as the pull down list, which I'm showing you. So the palette selection is the same in a Mac and a PC, but the interface is slightly different, and we have this nice color set. They're quite limited colors, but I've got the option of modifying them with their opacity, or I can pick a color wheel and it takes that default color, and then I can start to play around. I won't go into it in too much detail, but it's quite nice if you create your own custom palette. So if I go into my Paint Bucket tool, B for bucket, keyboard shortcuts are great in SketchUp, they're really simple. But one of the options I've got is I've got a list here that says Faro and Ball. So I've imported all of the Faro and Ball colors. Or if I'm doing construction detailing, I've got a construction detailing palette. And these are just textures that I've imported that help me use the same palette of materials again and again and again. So if you've got a PC, I'm sorry, but you haven't got the crayons.
I thought it might be a PC and Mac question. Thanks, Joanna, and thanks, Paul. We'll take maybe just a few more questions because I know that we're over the hour now, but I'll try and fit in these last few. There's a question here from Sam. Hi, Sam. With that last instance where you created terrain from your own data points, can you not use Toposhaper once you've lifted the points up in space? Does that make sense?
Yes, you could. Yes. The only problem with using the Toposhaper or Toposhaper is Toposhaper requires that there are data points, specifically the word point, and there aren't points where the geometry that you create, it doesn't create a point. However, what you can do is if you've got quite a large set of things that you've had to elevate, markers, what you can do is if you go to where is it? I think it's in tools and was it in extensions? Guide tools. There's a guide tool. I think guide tools is by TomTom again. It's in the SketchUp extension warehouse, but it allows you to create a control point at different things, different centers. So you can pick the arc center, or you can pick an edge-to-edge intersection, which is exactly what we've got here. So you'd have to pick all of this geometry. I think I'd probably have to explode it, but if I explode the geometry, you could explode all of them at the same time, so it's not hard. Run the extension guide tools, and then create a center point at edge-to-edge, or let's try the arc center, circle center. And then I'm just going to erase this just to see if it's created a point, and it hasn't. So when I did my drawing, it broke the geometry that was a circle. So I could just simply pick 2 lines here, and I hope that it would create the guide tools at edge-to-edge intersection.
Great, thank you. Let's do one more question. I've put the Elmtec website into the chat for everyone if you're interested in signing up for Paul's other sessions tomorrow and Monday and Tuesday. And also, don't worry if you can't make it. All these sessions are being recorded and they'll be up on Elmtec YouTube next week. We've got one more question from Sue. Hi, Sue. She's saying it's not entirely related, but what's the name of your colors tool with the pencils, please? Is it a plugin?
I'm thinking you're talking about the crayons again. And no, it's not a plugin. I'm guessing you're using a PC, so it's just a Mac interface.
Right.
So
yeah,
SketchUp works exactly the same in Macs and PCs. There's just 2 or 3 interface changes, and the paint bucket tool is one of them. And the other big one is the default tray. And there are pros and cons on both interfaces, and there are things that annoy me on both. But it's just one of those things, I'm afraid.
Yeah, that's what I thought. Yeah. Okay, everyone. Thank you, Paul. If there are any more questions, Paul is gonna be back tomorrow at 10. And you're free to email me or Paul any of those questions that didn't get answered. And yeah, I hope that you found it all. I'll send it over to Paul now to sign it off, but hope to see you tomorrow.
Okay, thank you very much, and I hope to see or hear from you tomorrow.